Okay, so on this one, we're going to graph both an exponential and a log. It's going to be interesting. So we see over here y equals 3. Well, here I'm just going to start by making a table. So remember, we have right here graphing an exponential. What do? Make a table and first plug in an x value that will make the power 0. So you first plug in an x value that will make the power 0. Oh, and by the way, let me mention, this is really new for us on this problem. The number that's out here is the horizontal asymptote. So let me just put that in right now, -2. So the horizontal asymptote down here at -2. Exponential graphs always have a flattening outline, but a horizontal asymptote. And that's always the number added or subtracted off to the right. That's going to be in the notes soon. I'll put that in the notes for you. So then any number added or subtracted off to the right of an exponential function, that's the horizontal asymptote. Okay, let's make our table. And so when we make our table, our xy table, what we're going to plug in, remember, is whatever makes the power 0. So we have, let me write it up here, y equals 3 to the x plus 1 minus 2. So what can I plug in up there for x that will make that power 0? -1, right? So that equals, scribble off here, that is 3 to the 0 minus 2, which is 1 minus 2, -1. Are we good so far? You plug in, so remember, let me write a note again. You start with an x that makes power become 0. So that made the power become 0. -1 plus 1 made the power 0. All right, so that's our first point. Back 1, down 1. So that's it's right here. Back 1, down 1. And now, what do? You just add 1. So this will become 0. Let's plug in 0 now. So y equals 3 to the 0 plus 1 minus 2. The 1 minus 2 minus 1 is 1. Over 0, up 1. Like that. So there's our second point. So all you got to do, so on this, the graphing tool, what it wants you to do is first choose the line tool. You know, the straight line tool that has the 2 dots with the straight line. It wants you to first choose the line tool, the straight line with the 2 dots, and go dot, dot, and make the horizontal. Oh, it says vertical asymptote. That's a mistake. It should say horizontal. For the next one, it'll be vertical. Does it say? Oh no, I'm getting confused. I'm not sure. Let me see. It will be vertical for the next part. Let me go see what they have. Like that. So I'm going to go check. This is number 2 in the 6.4 lecture homework. All right, let's see how it looks. Here's number 2. You see in my screen. Oh yeah, first I didn't put this on the screen. First, the horizontal, yeah. So first you click down here on the line tool, and then you put in the horizontal asymptote. Now, what is the horizontal asymptote? It's at down. This one, anyways, at down 2. It's hard to see where the 0, 0 is. It's right in the middle. So boom, you put your horizontal asymptote on, and then you graph your exponential, which is this tool right here. See the exponential going up? So that's the tool. So 0, so I'm putting -1, down 1, boom, and yeah, this is exactly the same thing. And then over, and then when you plug in over 0, it's it up right there. There we go, just like that. So first I did the line tool, click, click at -2. Then I put in these 2 dots, got that graph. So there we go. So let's go back to the iPad now. Okay, and so it makes the graph automatically for you right through those points. The exponential graphs always flatten on one side and rise up, explode upwards on the other. Okay, now coming down here, we're going to do the same thing. We're going to graph the log. So to graph the log, we're going to make an XY table again, and we're going to start with an X that makes the inside of the parentheses equal 0. So what can I plug in there? 1, positive 1. Plug that in, and you'll get y equals log base 3 of 1 minus 1 plus 2. Log base 3 of 0. The low one goes low. Turn it into 2 logs. The low one goes low. Log of 0 over log of 3. That's an error on your calculator, which really means it's the vertical asymptote. So at x equals 1, this is the vertical. Here, let me use a different color. This is, the vertical asymptote. So I'll put that on. At x equals 1, there's the vertical asymptote. So log graphs always have a vertical asymptote. And what do you do from there? You add 1. So now that'll be 2. So let's plug in 2. So what do we get? Y equals log base 3 of 2 minus 1 plus 2. Log base 3 of 1 plus 2. So you put the log of 1 over the log of 3, right, like we've learned. Like that on your calculator, right? The low one goes low, that'll come out 0 plus 2, that'll be 2. So that's the point over 2 up 2 right here. Over 2 up 2. And now we need one more point. What do we do? Well, you can just add 1 again, but it's not going to be clean. We'll go through the formalities anyway. So if you just add 1 again, you're going to get y equals log base 3 of 3 minus 1 plus 2. And then if you hit the buttons on your calculator, so the low one goes low. The one that's on the base goes to the bottom. Whoops. And that's going to be some decimal thing. I'll check it here. I'm getting 2.63. Now that's a fine point, but we can't find that on the graph, right? It won't let us do decimals. So what are we going to need to do? Just go up by 1 again. Just keep going up by 1 till you find something clean. The next one will work. It'll be clean. So the next one, we just say okay. So add 1 again. That's 4. Log base 3 of 4 minus 1 plus 2. Log base 3 of 3 plus 2. The base goes to the bottom. Of course, they're the same. It doesn't really matter. They're both just log 3, aren't they? So that's clearly 1. They're the same thing. 1 plus 2, which is 3. So over 4, 1, 2, 3, 1, 2, 3, 4, up 1, 2, 3, right here. Over 4, up 3. There it is. There's the log graph. You put those two, so you have to click. So the first thing I want you to do is click two places, any 2 points on to make that vertical asymptote line. Any 2 points. See how so I started here. I just clicked any 2 dots that are over 1 to make the vertical asymptote, which is at over 1. Any 2 dots. You go here and down here, whatever. Any 2 dots that are over 1 to make the vertical asymptote line, and then click the 2, 2, and then click the log making tool. So first you start with the line making tool, right? The line with the 2 dots. Click on the line making tool. Click the 2 dots to make the vertical asymptote line, and then click to the log tool and do 2, 2 and 4, 3, and it will make your graph. By the way, notice that these graphs are mirror images of each other. Like if I put one of them onto the other one, like I don't know if I'm at risk of messing it up. Let me grab like the exponential and put it down here. First off, you'd put that dotted line right down here at -2. No, that wasn't very good. There you go. And then the graph, over 0, up 1, right here. Over 1, down 1, right there. And the graph goes like this. Oops, I kind of missed it there, didn't I? Oh, I keep missing it. Sort of goes like that. See how those guys look like mirror image reflections of each other? Like that. They're close to it. The logs and exponentials are inverse functions from each other. That's kind of the point of this example, is to show you that these guys are mirror images. What do I mean? Mirror images across the diagonal line. That I should have said that previously. So they're mirror images across the diagonal line. Remember, I don't know if you remember from way back, inverse functions of any kind. So any kind of like a square root of x and an x squared, or anything else. They're inverse functions of each other. They reflect across the diagonal line. So there we go. So the key we see, let me recap real quick. To graph an exponential, you start with whatever makes the power 0. Plugged in -1. And then add 1, get another point. And the number off to the right, that's the horizontal asymptote line. Added or subtracted -2. And then for a log, you start by plugging in whatever makes the inside of the parentheses 0. Plugged in +1, that's the vertical asymptote. It'll give you error on the calculator. Then you just add 1, add 1, add 1 until you've got 2 nice clean dots. And that's how you graph logs and exponentials.